glucose. Glucose is the only one that's going to require any heating. So I'm going to take just one dropper full of glucose, and I'm going to add to it one dropper full of Benedict solution. Benedict solution is a little bit caustic, so you want to be careful when you handle it. You don't want to spill it all over the place. And it is preferred that you wear gloves, even though I'm not right now. Okay, now the one thing, just leave it there. One thing that we will need to put in to anything that you heat is a marble chip. It's old-fashioned, but I prefer marble chips because they're very effective in taking away the surface tension that builds up when you heat up water. Surface tension will cause a buildup of the heat that's trapped underneath the water and eventually can cause bumping. Can you get me a test tube holder in the middle drawer? Yeah. No, on the white drawers. Yeah, middle. Thank you. Okay, so we need a test tube holder. Doing this is not going to be helpful, especially if you don't want to get your fingers burned. And watch what happens as we heat the glucose with the Benedicts. Now you can get away with using a hot water bath. It takes a lot longer. This is more expeditious, but you have to know what you're doing. Do not ever look into the open end of a test tube being heated. You also, as part of being the operator, you want to make sure that the test tube opening is always facing in a direction where there's not going to be anybody there that might get hit. You also want to keep your test tube holder high up, because if you keep it low, your hand's going to be right in the flame. You want to keep moving your test tube, because if you keep it in one place, there's a great chance that one end will heat up and it may startle you when it starts to go up and out of the tube. As this is happening, you'll notice there's a color change occurring. Okay? The color change is going to be green to yellow, and then eventually orange, red, or rust. And you can see already. Along with that, there is a precipitate. And how do I know it's a precipitate? Because it turned cloudy from the original clear color, okay? Or the clear presentation of the solution. Do not do what some students do after they've done heating and go like this. I don't know what that means, but that's just a recipe for burning your fingers. So immediately put it down and leave it alone, let it cool off. This will eventually settle because it is a solid created out of liquid. It is a precipitate. Okay. The next thing we're going to do is the protein. And I'm going to add a little bit of gelatin. Gelatin, just a good old gelatin made from the hooves of animals, basically horse toenails, okay, or pig toenails. All right, people don't realize what gelatin is made up of, but it's protein. It's good protein, and from a standpoint of just a protein source. And we're going to use this very bright blue color agent, kind of similar to Benedict's in composition, and it will sting you if you get it on your hands. You have to wash it off. It is kind of a strong or hydroxide. And watch what happens. I'm going to have to hold this up so you can all see it. Watch what happens when I add a blue to a clear, colorless solution. Would you all agree this is a purple color compared to the original blue? Yes? Okay? And no precipitate. There's no precipitate there. It's still, you can still see light through it. If you can't see light through it, then there's a precipitate. So compare this to this. See? This one, you can't see light through it. This one, you can't see light through it. All right. What's our next move? Well, Let's take a look at starch. So I'm going to simply take a measure of starch. Starch has a hard time dissolving, so you want to make sure that there's enough of it in there. And then I'm going to add to it just a few drops of iodine. I don't need to put in a whole dollop of iodine, just a few drops, and watch what happens. Immediately, blue-black color, and it precipitate. Okay? And I can keep going, make it really strong, but I think that about does it. The interesting thing about iodine-starch reactions is it can work even at a molecular level of just a few molecules. If you just add a few molecules of starch, iodine would catch it, and next thing you know, there would be a color change. So we're going to actually use that in a lab much later on in the term. Okay? All right. We're going to use it for something called vitamin C assay in the lab. Last one is the oil one. So here I'm going to take a concoction of oil and water. As you well know, oil and water don't mix. So we're going to take some water and some oil, and we're going to drop it in here, make it look like a regular lava lamp. Okay? And of course, eventually the oil is going to move to the top. But what I'm also going to do is I'm going to add 1 squirt of Sudan Red. Okay, just 1 pipette full of Sudan Red. And let's see what happens to this in just a couple of minutes. In fact, you can probably see it in real time. As the oil starts to come to the top, it'll start picking up some of the red from the water, and in about 5 minutes you'll see that the oil will actually start to pick up a deep red or an orange color. Here you can already see, I don't know if you can see this or not, let's capture it. The top of the oil is already staining red. You see that kind of layer of red on top, all the way on top? And then there's a kind of a clear area, and then you got the rest. Well, as this continues, all the Sudan from here will wind up in the oil, and the water will become clear. Okay? So we can always recheck this in 5 minutes. All right, so to recap, we got a test for glucose, which is Benedict's. We have a test for protein, which is Biuret. We have a test for starch, which is iodine, and a test for the presence of of fat, which is in this case Sudan Red. The tests, if they're positive and it involves a chemical reaction, may or may not have a precipitate, but they will have a color change. All of them, with the exception of not counting the Sudan Red because it just infiltrated a hydrophobic area. The other 3 all had a color change based on the original color of the reagent. Okay? As far as the precipitates go, the Benedict's has a precipitate, and the iodine had a precipitate. Okay? Biuret did not have a precipitate. Okay? Any questions? Okay, thanks.